Hey guys, welcome to BBM Pulsars. In this video I'd like to show you a little upgrade I made to BBM Pulsar 5B 220 volt AC version. As you can see here, I have a stud diodes here instead of RURG80100 diodes, and I am testing it. Seems to be fine. It's not heating up. They're not heating up and they seems to hold. And that was the issue in the setup, which uses the strip coil. Let me show you the coil. So instead of a round wire 14 gauge, this setup uses 0.3 millimeter by 15 millimeter wide strip, copper strip, which is insulated. The weight of the coil is about 500 grams. It's 3 inches in diameter and a 1 inch inside diameter here. The whole circuit is made on this PCB. This is the yellow PCB for 220 volt AC setup here, and usually this one gets a regular coil, but I did some upgrades and I was able to use the strip coil, and that's why I'd like to show you the upgrades I did and show you the power output and talk about it for a few minutes. So the first thing I did is the upgraded the diodes, and these diodes are, let me show you, I got them from DigiKey. They made by Solid State Inc. 85HF40. There is a 40 available, and you buy them 10 at a time, and they cost almost $4 a piece. So that's one thing. Another thing is resistor. I don't make it by hand, I buy it. DigiKey has got 2 in stock right now. They're $16 a piece. This is made by TE Connectivity Passive Products, and this is the part number. When it comes to thyristor, which is upgraded thyristor here as well, it is a Semicron SKT55-10C, and if you can't find 10C, you can buy 12C. This is just a this one is indicates that it's for 1000 volt. 12C is going to be for 1200 volt. Either one will work. It costs around $80 a piece. Expensive, yes, but it works. So that's that. In this setup I'm using transformer. This is a step up power transformer. In my case it's 160 watt. Seems to be holding up a little bit, heating up at the end of session, but it's holding up. Now let me turn the unit on and test the power output. So from my previous tests, usually this 5B circuit puts out between 1 Tesla and 2.4 Tesla. Well, with the upgraded coil I'm able to, well, the power has increased a little bit, and I'm able to start with 1.1 Tesla and end at 2.6 Tesla. In addition, why I like this coil is you're gonna get almost twice more pulses from this coil before it heats up, and when it does cools down, it takes quicker for it to cool off, probably like 20% quicker. Let me go ahead and power her up so we can see the results. I have my Tesla meter configured. Okay, so let me reset it. Right there, it starts with 1.1 Tesla. It's pretty quiet, works very quiet. And as I increase the power, right here is the power increasement. I watch the power dial goes up 1.5. Let's see, 2.2. I'm gonna crank it up all the way. There you go, 2.621 Tesla. And another thing that I like about this 220 volt DC versus 120 is that it's fast. Between 2.6 Tesla it takes about 4 seconds. The 120 circuit takes about 7 to 8 seconds. So it's almost twice faster. Another thing I like about this coil is that it triggers the muscle. Let me demonstrate that for you. So I'm gonna increase the power all the way up, and I will put my hand and I'll show you. Now my hand is relaxed, and there you go. So you don't get that with 14 gauge coil, only with a strip coil. Strip coil is able to discharge capacitor bank faster, thus producing a sharper pulse, which is able to trigger the muscles. I haven't measured how short is the pulse. From my estimates, it's about 1 millisecond pulse. Okay, get it shut off. I'm gonna show you the bottom side of this setup here. Here we go. So I basically added small stands here, added a little board, and I mount all the diodes on the board, and then ran a wire. It's a 12 gauge wire. So all these pathways on the back are enforced with extra solder. In addition, there is a solder added into here and a little bit here, and I soldered capacitor bank to the board, the bolts. That's where the coil connects. Alright guys, so the only thing I don't like about this setup so far is the inductor. It has to be in front of the fan, just like the resistor. These are the two parts that do get hot if you don't blow the air on them. And so resistor and this inductor, these are the two parts. I gotta figure out something about this inductor, make it so that it's more larger or something. I don't know. If you guys have some ideas how to make it so it doesn't heat up, I really appreciate it. You can drop the comment down below. I'll be happy to hear it. I think that's about it. So I haven't tested for a long run. The reason why I decided to go with the stud diodes is because the RURG80100 they twice blew on me on this circuit, even with the transformer. So at first I thought it might be a faulty component, but then when it blew the second one, I figured that I gotta improve them. So when I put the stud diodes, they seems to hold on just fine. They don't get warm or anything. You don't need to put heatsink on them. Just like that, install them and you'll be fine. Alright guys, if you like the video, give me a thumbs up, subscribe, leave your comments, and I'll see you in the next one.